We're going to continue on discussing transformations. So we'll start with a quick little refresher, and then we'll look at how to find an equation of a transformed function when you're given its graph. Okay, so for starters, we'll look at question 6 from the text. It says the key point -12, 18 is on the graph of y equals f of x. So that point right there is on the original curve. What is its image point under each transformation? So I chose 6e because it had a little bit of everything. All of the parameters a, b, h, and k are evident here, and I'll show you how to apply them. So this will just review the mapping rule. So we're going to transform this point using these parameters. So for starters, I move the +3 from the left to the right, and now my equation is in standard form, and I can see my a value is -1/3. So that would mean two things, all right? It would be vertically compressed about the x-axis by a factor of 1/3. The negative would indicate that it is also vertically reflected in the x-axis. B is 2. That means it would be horizontally compressed by a factor of 1/2. I got to take the reciprocal of this. There would be no horizontal reflection in the y-axis because that's a positive. Okay, so remember, use reciprocals. Remember, when stating stretch factors, you always state them as an absolute value. So I said this was a vertical stretch by a factor of 1/3. I didn't say the negative. H value is -6. That means it's translated 6 units to the left. K value is -3. That means it's translated 3 units down. Notice when I took the +6 out of the brackets, it became a -6, and I translated left. The mapping rule is going to look like the following. It will be 1 over my b value, 1/2, times x, plus h, so plus -6 or -6, and then comma, a times y, so I use this -1/3 times y, and I'm going to add a -3 or subtract 3. The only time I leave this negative out is when I'm verbally asked to state, or I'm asked to verbalize the stretch factors. When you're making your mapping rule, be sure to include the negatives. So, set of instructions for the x values. So I'm going to take this x value, -12, and I'm going to multiply it by 1/2. That would give me -6. And then I will subtract 6. Well, -6 minus 6 is -12. And then this is a set of instructions for the y value. If I replace the y with 18, this number right here, -1/3 times 18, that would give me -6. -6 minus 3 would give me -9. Okay, and there it is. So that's a little refresher or a little review of writing an equation in standard form, picking out the parameters, creating a mapping rule, and then transforming a point to find its image point. That point right there, sorry, this one right here is on the original, that's on f of x. This point right here is the image point on the transformed curve. I'm going to show you question 4. I assigned it last night, but I'm going to show you how to do question 4 with this next example. So the task here is to write the equation of the transformed function. This red curve is the transformed function. This blue curve is the original. Okay? We want to determine the equation of the red curve. So in order to do that, I need to find A. I need to figure out what B is. I need to figure out what H is. And I need to find the parameter K. Once I have all 4 parameters, I can make my equation. Here are the steps. Okay. I like to do them in this order. Right? Really doesn't matter what order you do them in, but for the sake of consistency, I would suggest you do the same. So for starters, we have to ask ourselves, is the red curve reflected? Okay, now remember, if you flip the blue curve across the x-axis, if there was vertical reflection, the red curve should be, we'll say, opening downward. Didn't happen. So there's no vertical reflection. Is there any horizontal reflection? Well, if there was horizontal reflection, this point would go over here, this point would go here. The curve would look identical. Why? Because it's centered around that y-axis. It's centered around the line of reflection. So I can't even tell if there is horizontal reflection. If I can't tell, we'll assume that there's none. So for step one, when it comes to reflections, I will say there are none. That means that A is greater than 0, A is positive, and B is positive. All right? Then I'm going to go after my vertical stretch factor. So in order to find the vertical stretch factor, I am going to look at the range of each curve. So let's look at the range of the old curve, the original. It went from a y value of 0 to a y value of 4. The total range of that curve, and I do these in red, the total range is going to be 4 units. From 0 to 4, that's 4 units. Now let's compare that with the range of the transformed curve. This had a range, went from 2 up to 10. That would be 8 units. So it looks like the range went from 4 to 8. I actually doubled that. Okay? So here's the calculation. I'm going to take the new range, so to find the vertical stretch factor, and I'll call it VSF. I'll take the new range, which was 8. I'll divide it by the old range, and I get the VSF to equal 2. Now remember, what parameter goes with the vertical stretch factor? And that's the A value. And remember the relationship. The vertical stretch factor is equal to absolute A. So if the vertical stretch factor is 2, A is 2. If there was a vertical reflection in the x-axis, I'd make this a negative. Now I'm going to compare the domain. So I'm going to go horizontally here. Domain is from -4 to +4. So from -4 to +4, that is 8 units. Look at the new domain. It goes from -8 to -6. That is only 2 units wide. And remember, it's the new domain over the old domain. So it's going to be 2 divided by 8. So this is the horizontal stretch factor. It's 2 over 8, or the horizontal stretch factor is going to be 1/4, or 0.25. Now remember, if the horizontal stretch factor is 1/4, what does that mean the B value would be? Well, the answer is it is the reciprocal of this. What's the reciprocal of 1 over 4? If I flip that, I get 4 over 1. So my B value is actually 4. Is it positive or negative? Look here. Okay, there was no horizontal reflection, in the y-axis, or at least I couldn't tell if there was. So we said we'll assume there is none. So I'll leave that as a positive. Okay. Now, on to translations. Clearly you can see that the red curve, or the blue curve, in order to get the red curve, the blue curve had to go to the left and up. So I'm translating left and up. I want to use this point right here, 0, 0. I don't have to use it, but I would suggest using that point. It's easiest if you use that point. It became -7, +2, this point. Okay, note that this vertex coincides with this vertex. That point 0, 0 on the original became -7, 2 on the transformed. That is its image point. And again, it doesn't matter if you do horizontal translation before vertical translation. But just remember, here's a suggestion. It says pick a point on the original where x equals 0. So on the original curve, if I'm looking for horizontal translation, I want to pick a point where the x coordinate is 0. So somewhere along the y-axis, that's this vertex. So remember, 0, 0 became, what did it transform to? It became -7, 2. Okay, so let's focus on the x coordinates. Now realize I should be multiplying this 0 by 1/4. But by picking a point where x is 0, 0 times 1/4, that's just 0. I'm isolating the translation here. Okay? So 0 times 1/4 is 0. And then what would you add to 0 to get a -7? Well, I would add a -7. So that means that h is -7. Okay, I went left 7. I just want to show you that the h value, if I used, say, this point, and its image point would be this one here. Okay, so that's -4, 4. And that is -8, 10. If I don't pick a point where x is 0, so x is not 0 here, it's -4, then I have to remember to apply the stretch factor first. I'd have to multiply that by 1/4. So if I go -4, 1/4 times -4, and then subtract something, it should give me -8. So what's 1/4 of -4? That would be a -1. Okay, well, what would I subtract from the 1 to get a -8? The answer is 7. Okay, so you can see that the horizontal translation is still 7 left. So for vertical translation, pick a point on the original where the y-coordinate is 0. So again, I'll use that same vertex because now the y-coordinate is 0. It still became -7, 2. So for this question, I'm using the same point for both. Only I'm going to focus on the y-coordinates. Now remember, I really should multiply that by the vertical stretch factor, which is 2, and then try and figure out the vertical translation. 0 times 2 is 0, and then I would have to add 2 to this 0 to get this 2. So my k value is 2. I went up 2. All right, let's see. I should get a 2 here as well. All right, if I go 2 times this 4, that gives me 8. What would I add to the 8 to get this 10? Okay, well, I'd have to add 2. So this here is me using the stretch factors as well, but I would suggest picking a point on the original where x is 0 when looking for the horizontal translation, or where y is 0 when looking for the vertical translation. Then you don't have to worry about either stretch factor. All right, when I go to write my equation in standard form, this is the task, y equals. I'm just going to fill in these parameters. A is 2. Remember, B was 4. The horizontal stretch factor was 1/4. It's the B value that goes into the equation. And then I will write x, instead of writing minus -7, okay, I'll just write plus 7 because 2 negatives make a positive. Close the brackets twice, and then I'm going to add 2. Okay, there's the -7, there's the positive 2. That is my equation. All right, and if I go up here, we should see the same thing. Perfect. That means I did it correctly. All right, I'll do one more example. All right. And with this one, same job, determine the equation of g of x. So first of all, identify which one's the original and which one's the transform. Well, here's g of x down here. And I'm going to color code these points. This point goes with this one. This point has its image point at positive 3 comma negative 4. There's the image point. There's the image point. So check this out. This red and blue point, they were above the x-axis. Now they're below the x-axis. They went from above to below. So if they got flipped across the x-axis, that means there is vertical reflection in the x-axis. And that means that A is less than 0. My A value is a negative. Okay? Check to see if there's horizontal reflection in the y-axis. Check it out. The blue and green point there on the right, they're still on the right. They didn't go to the left, or the black point didn't go to the right. So there is no horizontal reflection. Okay? So we can say that B is a positive. I'm not going to say no horizontal reflection in the y-axis. I'll just write a little note here that B is greater than 0. It's a positive. Now I'm going to get into the range. Okay, height of 0, height of 4. That's 4 units. Okay, here's the new. That's a height of negative 4. That's a height of 0. That's 4 units as well. So remember, it's the new. It's this number over this number, 4 over 4. So for the VSF, vertical stretch factor, I'd go new over old, 4 over 4, VSF equals 1. That would mean that A is a 1. Now be careful. Look above. Is it a positive 1 or a negative 1? Well, because there was vertical reflection in the x-axis, this tells me to put the negative here. Let's go with, do this down here. Go from negative 7 all the way over to positive 13. Okay? The domain of that would be x is greater than or equal to negative 7, but less than or equal to positive 13. That is a span of 20 units, from negative 7 over to 13. This is a negative 2. This is a positive 2. That's a span of 4 units. Remember, it's the new 20 over the old 4. So for the horizontal stretch factor, I'm going to take 20 and I'm going to divide it by 4. That gives me a horizontal stretch factor of 5. Now be careful. The B value, the parameter B, would be the reciprocal of 5, which is 1/5. Look to the step 1. Is it positive or negative? Okay, it would be a positive. I don't even need to write that. I'll just put it in there just because. For the horizontal translation, pick a point on the original where x is 0. Again, this eliminates me multiplying by 5. Okay, where x is 0. This is the original. The only point where x is 0 on the original is the point 0, 4. Okay, 0, 4. Pardon me. 0, 4 is going to become 3, negative 4. That's its image point. Now remember, focus on the x-coordinates. You could multiply it by 5. 0 times 5 is 0. And then what would you add to 0 to get a 3? Well, the answer is 3. My h value would be 3. I went right 3. For vertical translation, okay, I want to pick a point on the original where the x is 0. And it doesn't matter. I could use the black point. Okay. Sorry, where y is 0. I could use the black point, or I could use the green point. I'll go with the black. So the black point is, that is at negative 1 comma 0. This is at negative 7 comma 0. So negative, oh, sorry, not negative 1, negative 2. Each block is 2. So that's negative 2 comma 0. It became negative 7 comma 0. Negative 2 comma 0 became negative 7 comma 0. I just want to show you that again. We're talking about this point, negative 2 comma 0, and this point, negative 7 comma 0. Really, I should be taking the y values and multiplying them by negative 1, right? 0 times negative 1 would be 0, but I don't have to do that if I'm picking a point where y is 0. And then what do you add to a 0 to get a 0? Well, nothing. K would be 0, means it's not translated vertically up or down. When I go to write my equation, I will write y equals, the a value is negative 1, my b value is, now remember that's this number, positive 1/5. I'm just going to write a 1/5 in here. Open your bracket. It's x minus 3. Close the bracket twice, plus 0. Now this is how you would see that written in the textbook. 1/5 x minus 3, and that's it. Okay, let's see if we got that right. Of course we did. Okay, so full screen so you can see everything all together. And this is how you would do question 4 from the textbook. You can continue working on, let's see, these questions right here on page 38.